Hello guys, welcome to my channel Electrotech Center. Today in this tutorial we are going to learn how to interface LED to 8051 microcontroller and how to write program for that. So we'll first see schematic design in Proteus. So let's open Proteus software. So here you can click on new project. So you have to give name for your project. You have to select path where do you want to save your project, then click next and finish. So here you have to first select component mode. In P tab you have to type your components. First I will select my controller 8051, then I will select crystal oscillator, then 22 picofarad ceramic capacitors, push button for reset circuitry, electrolytic capacitor, then register. I'm selecting general purpose register, one LED. So taking here animated red color LED visualization. So now we will connect all our component to our microcontroller 8051. First of all, we will see crystal circuitry. So we will rotate this crystal to align their pin to crystal pin. Then we will select ceramic capacitors. Okay. We will connect this crystal oscillator to pin number 19 and 18 of our 8051 microcontroller. So other terminal we have to connect to ground. Ground we will get in terminal mode. So select ground and connect it to capacitor pins. So this is crystal circuitry. So now we will connect reset circuitry. So for that we will need one push button, one electrolytic capacitor, and one resistor. So now connect this push button in parallel with this electrolytic capacitor. So connect 5 volt power supply to this electrolytic capacitor. Also connect ground to this resistor and connect 9 number pin, which is reset, to this circuitry. Now we'll connect an LED to port 0 pin and one register for protection. So I have connected all possible circuit and component here. So first of all we will see crystal circuit. So first we have to select this microcontroller and set this clock frequency as 12 megahertz. So this is first requirement. Then you have to select this crystal and also you have to change this frequency to 12 megahertz. So this two ceramic capacitor connected with this crystal with the value of 22 picofarad. So why this two capacitor needed here? We will explain this. So whenever any external noise or external magnetic field, any external signal is interfere with these crystal pins, this noise can disturb our crystal frequency and can get entered inside microcontroller timing circuitry or frequency circuitry. So that will disturb our microcontroller working. So to avoid that, we have connected this two ceramic capacitor. Whenever noise come, it will directly pass to ground through this capacitor 1 and capacitor 2. So this is all about crystal circuit. Now we'll see reset circuit. So pin number 9 is given for reset circuit and this pin is active high. Active high means whenever we apply 5-volt power to this pin, this microcontroller will get reset, and whenever we apply ground signal to this pin, it will remain in normal state. So there are two cases or scenarios to reset this microcontroller. One is automatic and one is manual. So whenever we turn our power on, a voltage change from 0 to 5 volt. That change from 0 to 5 volt act like a AC signal for this capacitor, and this capacitor will directly get short circuited and our power supply will get on the pin number 9. That's why when we turn on power, this 8051 microcontroller will become reset. So that is called power on reset. Okay. So this is happen when power is turned on. So what if we have to reset this microcontroller in running state? So for that purpose we have provided push button. So we apply push button, that 5 volt get attached to 9 pin and this microcontroller can get reset at runtime. So that reset called manual reset. So this capacitor value we have to take 10 microfarad and this resistor value you have to take 1 microfarad. So this resistor value should lower than this capacitive reactance value, then only this circuit can work properly. So this resistor we have attached to connect this ground to this 9 number pin. Okay, so this is all about this reset circuitry. So we have connected our LED to port 1 pin, which is active high port. So there are 4 ports, port 0, 1, 2, 3. These 4 ports each have 8 pins. So they are general purpose bidirectional input output ports. So you can use any one pin as an input or output. The only difference is that this port 0 is Internally there is no any pull up or pull down register attached to it, but port 1, port 2 and port 3 have internal pull up. So pull up is necessary when you use pin as an input pin. We will see that in next video, how to use pins as an input pin. So in this video, now we have to calculate this register value. So for calculating register value, you should know this LED specifications. Okay, so this LED is 5 mm LED and its maximum current is 20 milliampere and voltage drop is 2 volt. So according to it, we have to select this register value. So as we all know, resistor R is equal to V upon I. So means voltage drop and current flowing. Calculating these two values, we can get this register value. So for that, we should know the port pin output voltage, this voltage and current. So we have got here 5 volt, here 2 volt. So 5 minus 2 is 3 divided by whatever current we are limiting for this LED. So I am limiting here 10 milliampere. Its maximum rating is 20 milliampere, but I am designing it for 10 milliampere only. So we are calculating that resistor value. So 5 minus 2 divided by 10 milliampere. So we will get 300 ohm. So this resistor value, we have to set it 300 ohm. So in actual hardware, you can connect this component, and also you have to connect to 5 volt power supply to 40 number pin and ground to 20 number pin. So this is all about schematic circuit designing. So now we will see how to program for this circuit to run this LED. So for programming, we are going to use Keil IDE. So in Keil, you have to uh, open new project in project window, give any name and address. I am giving here desktop. Select your controller 8051. So you can select your controller version, which is 889C51 for 8051. So 889C51 is compatible controller version for 8051. So we can select it, select yes. So now here target is created, source group is created. Inside source group, we are seeing that startup file is created. So we have to add our C source code file. For that, I'm selecting C and giving here name test.2. So no need to give extension because we have selected it C file and type add. Yes, we have added our source file in our source group. So now I will write code and explain all code line by line. So I have written the code. Now we will return delay function. I have written delay function and code. Now I will explain line by line of whole code. So first line we have taken hash include register file 51.h. So we are including header file. So this header file is written for 8051 based microcontroller. So all SFR register and memory related mapping are stored inside this header file. So we will see what is inside this header file. So this is register 51.h file. Inside it you can see all SFR related information like port 0, port 1, port 2, port 3, PSW, accumulator B, all register and their relative address are defined as a micro. Okay, ES bit is also micro. Okay, S bit and HFR. Two kind of data types micro are defined here and their relative address are given here. So that is about hash include register 51 header file. So we are using S bit data type for defining port 1 0 pin as a LED. You can give your name as per your requirement. We are declaring delay function here. Inside main I have taken while loop because I have to make LED on and off for infinite time. So that's why I have taken this code inside while loop. So first I am making LED 0, giving some delay, then making LED high, then again delay. So like that this will work indefinite time. So inside delay function, so whatever integer passed by this user, it is taken in I variable. So there are four loops in delay function. So this internal for loop is for millisecond delay and external for loop for user input. So whatever user is giving that number of time this internal for loop will execute. So this 122 integer is I have calculated by trial and run method. Okay, now we have to do some setting for generating hex code, and we have to also set the 12 megahertz frequency for 8051 microcontroller. So for that you can go inside project tab, option for group source one. Okay, here you can see crystal frequency is given 24, but for our controller it is 12 megahertz. And in output tab you can see here create hex file, so that you have to check for generating hex file. So click on OK. So now you can build this code to check no error, zero error and zero warning, and hex file is also created. So to check the output we can debug the I am running it. So to check output, go inside peripheral, IO port and port 1. So you can see here port 1 pin is blinking. You can also check it on logic analyzer window. So go inside view, analysis window and logic analyzer. So here logic analyzer is shown. So expand it. So now it is not shown any output on this window. So for that we have to do some setup. So click on setup. Here new option is given. You have to click on that. Give any name. Okay. So now select it, change it to bit as our output is digital. If your output is analog or state or bit, you have to select as per that. You can change color also. So now close this window. So here you can see the output of port P1.0 is shown in this window. So see it properly. You have to, sorry, in setup you have to give port name. Yes, you can see the output. So to check the time period, you can stop this wave. So you can select starting point and ending point. So here you can see in delta option, time period is given 1 second for this off period. For on period, you can select this period. So in delta, it is showing 1 second. That means our code is generating exact 1 second of delay. So code is right. So now we will upload this hex file in our Proteus simulation. So stop debugging this process. So you can see here hex file is generated as text2.hex in object folder. So remember this address. So now we will open, double click on microcontroller, set this frequency to 12 megahertz, and here option is given program file. You have to browse your hex file. So test.2.hex is my hex file. You have to open it. You have to check crystal frequency. Yeah, it's 12 megahertz. It's right. So now you can run simulation to see the output. So now LED is blinking as per our program. That's mean our code and circuits is correct. So to load hex file in actual hardware, you need external programmer. Okay, so that by using that programmer you can load your hex file in this IC. You have to also connect power supply of 5 volt to 40 pin number and ground to 20 pin number, which is not shown in this schematic. So that is all about today's tutorial. In next tutorial we will see how to interface key to this port pin. So thanks for watching this video.